topics. Let's first start with big data and AI. And it's my pleasure to welcome on stage Anukool LAKHINA, founder and president of Guavus, on stage. Let's try to learn what's AI, big data, and those kind of technology lights for the future.
Thank you.
If you want a clicker, it's on the other side of the stage.
It's on the other side.
Yeah, we like to keep our speakers fit, you know.
It's a good exercise.
A little bit of gym on stage in the morning.
Thank you. I want to talk about, if I can get these slides to work.
It's going to work in a few seconds.
OK.
Just click on the green button, and it might work. Or we might need a startup to invent something different to disrupt, actually, remotes on stage and slides. OK, who's willing to disrupt this kind of technology?
Let's try
just
the red button?
No,
Probably not.
The green one. You want to press on the green one. Always go for green. Or maybe the regie can be a little helpful here and help Anukool to get those slides ready. OK, you know what? Let's do it live.
OK.
What's about the future? What's about AI? And what's about your business model? How are you going to disrupt big data?
So, I think it's probably important to kind of step back and ask the question, why did data become big, and so what? And the reason that data became big, and it kind of feeds in very nicely to the discussions that we've been having today, is because sensors and machines got connected, and they started generating data. So for the first time, you really have machines generating data, and therefore, you need machines to analyze the data, and hence the advent of artificial intelligence. So, good, I got my slides here.
Go.
So now I can kind of feed that right into what I wanted to talk about today, kind of give you my perspective on where we are with respect to real-time big data and AI, and also where I think we are going to go. And the perspective that I bring to this problem or this topic really goes back about 15 years. As part of my PhD work, I was lucky enough to be at Sprint Labs. And 10 years ago, before big data was a phrase, before big data was a word, Sprint Labs in California had a really audacious, some would call crazy idea. And the idea was this. The idea was, what if we can put sensors across our network and start collecting data about what our customers are using our network for? Pretty intuitive idea, but it was actually fairly challenging to go about executing this, because what would happen is they would deploy these very, very expensive probes, very expensive sensors inside their network, and once you would turn them on, you would just start filling up hard drives with all this data. So what you would have to do was turn on the probes, shut off the probes, take all the disks, and actually it turned out that it was cheaper to use the FedEx network to move this data around than the Sprint backbone network. So the engineers used to joke, they used to call it package switch networking versus packet switch networking. So those were the days where, 10 years ago, before big data was a word, before data science was a phrase, this is kind of how I started off, and the company that I founded, Guavus, which is now a Thales company, really was at the forefront and got a front row seat into how this whole big data landscape has evolved. The fundamental problem that Sprint was trying to solve, and I believe the fundamental class of problems that now become available once you start connecting sensors and instrumenting sensors to measure the environment, is what we call the data insight action problems. So fundamentally, it's really about collecting data from the environment, correlating that data with other sets of data that exists inside the business, analyzing that data, and ultimately trigger an action right back into the network, right back into the environment. So this is the kind of cycle of closed-loop decisioning or data insight action that has to be done in real time. And really what sensors allow you to do is, for the very first time, I believe, in human history, is we have the power to know the now. We've never had this capability, so we've always relied on theory. But now we can rely on data, and data from up to the most recent minute. This is where it's going. Telcos were at the forefront of this because they started putting these instruments in their network, but I believe every industry, aerospace, defense, transportation, I think every industry will go through the exact same phase. So one of the things that you recognize when you want to do real-time decisioning on all these streams of data is you kind of have to throw away everything that has existed over the last 20, 30 years. So we've been talking about disruption a lot at this event, and you somewhat have to disrupt the way that data analytics has been done. Traditionally, data analytics was done on small amounts of data when you wanted to do analysis over when timeliness was not important. You could wait for a day to get your results. You could wait for a week to get your results. And therefore, the architecture really was take data, collect data, transport it to a central place, store it, index it, and then query the data, ask questions about the data. As I said, that works really well when you have small amounts of data, but when you have large amounts of data that are continuously being generated, you don't have the luxury to move this data to a central place, store it, index it, and still try to get real-time insights out of it. And the reason for that is it's a physics problem. You start writing to disk, and then your queries start running, and they never catch up. So essentially, the store and query paradigm, which is really the foundations of how, if anyone over here has taken a database course, if anyone has kind of worked on a BI system, this is really the advent of the relational database, 1980s. This is kind of how we've all been trained to think about data. Well, guess what? You got to kind of throw that away and start afresh. Instead of store and query, you have to do query and store. So what that really means is as the data is coming in, analyze it in flight, extract what you want from it, quickly make a decision, and trigger an action right back in. And hence, the paradigm is a streaming paradigm versus a store and query paradigm. The second thing that you need to recognize when looking on sensor-generated data is the kind of data is machine-generated data, and the parameters and the features and the volume of this data is fundamentally unprecedented than the data that we've known prior to this, which is human-generated data. And therefore, if machines are generating the data, we need to rely on machines to analyze this data, and hence artificial intelligence. This data is not only very versatile and very low level, but it's also constantly changing. So it is impossible for a human to reason about trillions of time series, billions of objects simultaneously and be able to make quick decisions. And therefore, machines have to come in to help us tame this avalanche of data. So together, if you take kind of real-time data and you take artificial intelligence, they seem like very good companions. However, that said, we still are a far way from where we need to be. Today, if I was to use a metaphor of a phone, of a smartphone, today, if somebody wants to extract value in real time from sensor-generated data, it's really a self-assembly model. Instead of kind of downloading an app, you actually have to build the phone first. So today, it's really a self-assembly model, integrate the parts, bring it together, and therefore, this is really resided in the hands of too few. Only the large corporations, which can afford to spend $100 million on embarking on big data programs and hire hundreds of data scientists, can really start seeing the benefit of this. Where I think we will go, and where I'm already seeing us go, is this is all going to become commodity. This is going to become like an app store. Very simple, very democratized, and we're already seeing the signs of maturity in technology to get us to that point. And I think, in 5 years from now, in 10 years from now, we'll be talking about automated, intelligent decisioning systems that will be democratized for anybody to access. Similarly, artificial intelligence has gotten a lot of press, a lot of buzzword. Fundamentally, if you kind of just step back from all of that, artificial intelligence is trying to solve the following problem. Any intelligent system will automatically recognize, automatically reason, and automatically or autonomously respond. So this phenomenon of recognizing patterns, reasoning about what's going wrong, what's happening, and then responding right away is really what artificial intelligence is all about. Where the advances that have been made recently, if you step back, I'd say about 15 years ago, IBM, beat Kasparov in chess. And when that happened, people said, oh goodness, the machines are taking over the world, and and so on and so forth. But really, the real insight over there was you don't really need. Chess does not require intelligence. Chess requires computation. And then when Google beat Go, the same kind of Google beat the world champion at Go, the same kind of doomsday prophecies were told. And the key thing to recognize over there is machines are actually much better at recognizing patterns than humans are. Which is why, if you look at the buzz today, it's really around self-driving cars, self-driving trains, because machines can recognize patterns from video streams, from audio streams, much better than we can. I was sitting here somewhere and I saw somebody with a phone and the Google Translate device, so it was quite interesting that the machine was actually translating in real time while the speaker was speaking. So this is just the beginning of what we're going to see. Automatically and autonomous recognition is I would say months away to becoming mainstream. This is already happening. Big research dollars have already been spent on this. What hasn't been, where the frontier is still open, is on reasoning. So what is reasoning? Reasoning is being able to bring in domain knowledge, bring in human awareness and say, based on everything that I've seen, this is actually what's happening. Here is the root cause. This is a hard problem. The good thing is there's a lot of research being done on this. So I feel like this is the next frontier of AI, and you need the reasoning to fully get towards autonomous intelligence, which is recognition, reasoning, and then finally response. So that's where I believe AI will move towards. So putting this all together, when you take sensors and you connect them, you generate data. This data is machine-generated data. Therefore, you have to use machines and artificial intelligence to reason about this data. And because this data is telling us something about what is going on right now, for the first time, we have the ability to respond right now. And so putting this all together, this idea of data inside action, sensors generate data, you analyze it using machines, and then you trigger an action right back into the environment, is really the foundation of what I believe will be the next data fabric powering us for the next decade and beyond. Security is foundational in this. You cannot ignore security, and security means lots of different things. Obviously, when you're reasoning about this very sensitive data, you have to kind of lock down the system. You want to make sure it's secured access. Simultaneously, when you're thinking about AI models, I will caution, not to the extent that Elon Musk says it, but I will caution when people start looking at black box models. Black box models, when machines are doing things that we don't understand, can be reason for concern. And therefore, part of security has to be to embrace open models so that you can actually debug the machine. You can actually diagnose what the machine is doing. And finally, when you're doing automation and you're responding in real time, it is important to consider the expert in the loop. You don't want, not immediately, you don't want machines just starting to react automatically. It's important to have an override function that an expert can bring in. So that is what I believe will be the emerging decisioning fabric in the time to come. The good news is this technology is being built. I mean, certainly Guavus has been building this for the last decade. And let me give you some examples, some real-world examples of how this technology has been applied by forward-thinking telcos, primarily in North America so far. And this has led to real business value, real savings. So, one of our customers is a tier one broadband operator in North America. They spend about $1 billion a year in dispatching technicians when something breaks down. So customer calls, says something is broken in my home. They don't know how to solve a problem. They send a technician to your house. And more often than not, the problem is not in the house. It's somewhere else. Well, with big data and AI, what you can do is you can start looking at data from the network, telemetry data. You can bring data from the customers, and you can start reasoning about what's going on, predict these failures, and therefore trigger the right action, which is trigger the right technician to the right person, to the right home at the right time. And this leads to real quantifiable, measurable savings. This is not funny money. This is real money. In year one, you're talking about $70 million worth of savings for this operator. Let me give you another example. This is an operator, a Tier 1 mobile operator in North America, and one of the things that they offer is an all-you-can-eat plan. Do whatever you want, consume whatever you want. And what happens as a result of this is people abuse it. People take their mobile phone, illegally tether, and as a result, you have a few abusive subscribers that make it bad for everybody else. So again, this is a problem that closed-loop decisioning can actually solve. Measure data from the network, understand who are these abusers, and then intelligently trigger a policy back in the network to clamp the abuser traffic down. So here are two concrete examples of how this technology is not really of the future. This technology is today and evolving very quickly and results in real savings for telcos today. As I mentioned, Guavus is now a Thales company, and what we want to do is really take the technology that we've built, the data analytics technology that we've built and seen a great success with the telcos, and bring it into Thales's core verticals. So these are the industrial houses. So we really believe there's a lot of value when you can combine data analytics technology with industrial technology. And each of these industries is going through its own journey of digital transformation. Aerospace, space, ground transportation, defense, security, all these industries are going to get transformed with the advent of sensors getting connected, generating data, and therefore the need for artificial intelligence and quick response. So I started my talk by talking about what happened 10 years before big data. If I can be so bold and predict what will happen, we were just doing future of the future predictions, but if I can be so bold and kind of predict what will happen in the next 10 years, is I believe we will have these invisible systems that are silently but very importantly continuously collecting data, intelligently making decisions, and then triggering the right policy, the right business process, the right actions back into the environment. So we have seen instances of this already occur, and my view is that in the next 10 years, this will be pervasive. Every industry will have this. Every enterprise will, the enterprises that embrace this will stay on. The enterprises that don't will struggle. Thank you very much.
Thank you so much, Anukool.